I muted. I am going to start the class after another 2 or 3 minutes. 56566. Okay, let me start the class. I am going to record. You are all muted by me. If somebody joins also, I think they will not be able to talk. They will be also muted automatically. I hope so. Let me start recording.
Recording in progress.
Good evening, students. Today we are going to see another important chapter of our hybrid electric vehicle. In this lecture and next to 2 lectures, I'll be talking about energy storing devices, basically what we call as batteries and supercapacitors used in hybrid and electric vehicles. Okay, when we talk about energy device, especially we are talking about energy storing electrical devices, energy storing or electrical energy storing devices. Electrical energy storing devices is what we are going to talk. The first one will come into our mind will be batteries. Battery. Now, next to this one, especially for current generation of engineers who is working on vehicles, electric vehicle and hybrid vehicle, you will come across what you call a supercapacitors. These are the 2 items or 2 devices primarily used as energy storing device in electric and hybrid vehicle. When we talk about batteries, batteries are called as electrochemical energy producing devices. Since they convert a chemical which we call as electrolyte. If you see any battery, electrical battery, you will have 3 important components, which is called as electrodes, anode and cathode, and also a paste-like thing or liquid-like thing, which will be surrounding these 2 electrodes, and the whole thing will be inside a non-conducting vessel made of plastic, rubber, whatever this is, but it should be a non-conducting vessel. We call as a battery, in which it will be filled with electrolyte, which is a chemical, and there will be 2 electrodes. One is called anode, another one is cathode, and there is a chemical reaction happens between the electrolyte and the anode. Similarly, an electrolyte and cathode. This process is called as RODX, which is the short form of reduction and oxidation process. This is the primary process. Reduction primary process is crucial or vital in producing electrical energy in the form of electrons, and which will be allowed to flow through the load connected externally. I can say load connected externally, externally between anode and cathode of battery. Okay. So the prime, this one is mechanism is RODX process, which is called reduction oxidation process, which is happening inside a electrical battery. The next one is called as supercapacitor. Already we talked about supercapacitor when we talked about mechatronics or in electrical engineering. Definitely, even at school level, they are teaching. We know that capacitor is nothing but an electrical energy storing device specifically in the previous course in mechatronics. I told you we talked about this one. This is called as static energy storing device. Okay, so basically it also, this one I told you, the battery has anode, cathode, these are called electrodes, and electrolyte. These three are the key components of any electrical battery. Similarly, for capacitor, it has two conducting plates, which are separated by a dielectric material, dielectric or insulating material. Generally, we know that capacitor represents symbolically like this. Unit for the capacitor is farads. Maybe micro, milli, or farads. These are the units available. Sometimes even you have picofarads. Because capacitor available for picofarads. That is capacitance value is very small, 10 power minus 12. Of course, nano is there previously. Nano, pico, all those things. So it has, I say that P1 is plate 1, plate 2, and in between you have dielectric material filled with capacitor. Please note that it is not a, it represents symbolically. Basically, it can be two parallel plates. I can draw that, already you know it, but anyhow for completeness, I'll draw that. This is the P1, and another, there's a P2, another plate is here, which is a car, this one. In between, it is separated by a dielectric medium. I can say that there is a material, non-conducting material, which is placed in between these two plates. Okay, this is dielectric material. Then these are the plates, P1, P2 are this one. And if I connect electrical power, for example, battery plus minus, the electrons will flow through this and get accumulated in this plate. P2 plates will be accumulated with electrons. So this plate became a negative plate. Automatically, other plate will be positive. So the capacitor will have electrons at one plate, which is generated by the external power supply of the minus terminal plus so this come and get deposited in the P2 plate. Automatically P1 plate will be called positive plate, P2 is called the negative plate. So the number of electrons stored in the P2 plates decide how much energy is stored. How much energy is stored in capacitor depends upon number of electrons. Number of electrons stored in the this one. So that depends upon the size of the area of this capacitor, that is the plate P2. Generally the plates will be of equal size. The plates will be of equal size, and when both the size this one, then number of electrons stored decides the this one. That depends upon the capacitance value. Okay, so we know that the capacitors are most widely used in okay. So this is basic idea behind the capacitors. Are you able to hear? Because I unmuted because I am getting some issues in my screen. You can unmute and talk. Are you able to hear me and the screen is visible?
Yes, sir.
Yes, sir.
Can hear you, and screen is also visible, sir.
But here it is flickering. My screen was flickering. I was worried whether we are able to see. Okay, fine. Okay, we will see whether we can remove this part editing. Let us continue. Still, we are recording. Please don't talk. I can remove this part while editing, and so that we can share the video. Fine. So the capacitors is an electrical energy storing device similar to battery, and but most of the time the amount of energy stored in the capacitor depends upon the capacitance value. It depends upon the capacitance value. We know that when we talk about super capacitor, we will come back. Anyhow, for completed, we know the capacitor equal to A epsilon divided by D, where A is called as the common area of the plates between two plates. Epsilon is called as dielectric constant. D is the distance between the two plates. Okay, that is called as capacitance value. This capacitance value going to is how much energy, electrical energy it can store. Okay, that we will see when we talk about capacitor. Okay, right now, since we said there are two types of electrical energy storage, one is battery, other one is called capacitor. Okay, now we move forward with first with the batteries. Okay, we will move forward with battery. What is a battery? Okay, battery means a group. Literally, if you see the English dictionary, it is called a set. Correct. Group of people, set up items, or sets. This is not one item, a single item. Your group work together as this one. This battery terminology used in army also. They call battalion, a battery. Yeah, a commander will be there along with soldiers. They will going for fighting. They form a formation. They fight together as this one. There'll be a captain. Correct. So they call battalion, or sometimes they call battery also. Okay. So battery means group. Basically, in electrical, we always say battery. The correct terminology should be cell, electrical cell. It should be called as electrical. Sorry, if there is some issue, my screen is flickering. Not able to write. Just a wait.
Recording stopped.
I don't know. There is some issue with my writing pad. Today it is giving problem. It is continuously flickering. I'm not able to write. Just wait a minute. I'm looking what is the problem. I'm trying to see. His screen is visible still. Hello. Hello. Is it screen visible?
Yes, sir. Yeah.
Yes,
No.
sir.
No. From my side, where I'm writing, writing pad. So that's what you are seeing.
Battery cell we can
Sir,
see.
you are able to see battery hyphen cell.
Yeah, that's correct. But here it is flickering, coming and going. That's what I was worried whether you are able to see continuously.
We
Okay.
can see, sir. We can
Can
see.
you write now?
Sir, you can write now, sir. Just we will see, sir.
You are able to.
Yeah. Okay. So recording, don't worry. I will do separately. But right now, class will complete. You can, if you have questions, also you can ask all these things. I do recording separately. Don't worry about it. Okay.
Any problem?
Okay. So when we talk about a battery or electrical battery, but it means a set of cells. A battery is nothing but consists of a set of electrical cells. Okay. So the basic unit of electrical storage device, basic unit is a cell. Okay. Cell consists of, battery cell consists of two electrodes plus electrolyte. Three components are important. Okay. So now I can say that this is my cell, electrical cell. Generally, it contains a container. Contains a container made of electrically non-conducting material. Please note that initial batteries are made with wood also. Wood box, correct? They're filled with electrolyte. Otherwise, they use glass. Now we are using plastic, rubber, all this. We know that different synthetic material is used for making the battery. Okay. So cell also same. Okay. As I told you, a battery consists of multiple cells. Multiple cells packed together is called a battery. Is called as a battery. We will see that. We don't worry because most of the time, what are all automotive energy storing device, lithium ion, lead acid, or any other this one are batteries, not cells. Okay. The cell, for example, we call it dry cell. Correct. Dry cell we all know. Correct. Generally, we say triple A to double A. Correct. Single A. Generally, it will be cylindrical. We use it in our torchlight or in cell phone. Cell phone we use nowadays. This one, or calculators. All those things old. This one still we are using. We say triple A, all this thing. It looks like a cylindrical shape. This is the body, correct? This is insulator, and this is there will be a projection in the one side, correct? That is called as positive terminal, and bottom of this is called negative terminal, correct? So this is we call it a dry cell, correct? Dry cell consists of the zinc electrodes. Zinc and zinc oxide electrodes with some electrolytes, zinc waste, correct? Is a electrolyte, and it can produce 1.5 volts. It can produce 1.5. If you put a voltmeter, it will say 1.5 volts. Please note that the battery, how much? Cell. Sorry. Yeah, it's a fixed amount of electrical voltage and can produce maximum amount of current. Maybe 1 amps, 2 amps, 10 amps, all this we'll see what it is called battery capacity. And the amount of voltage produced by a type of cells, correct? I say dry cell, which is called a zinc cell. Okay, then lead acid cell we use in this one, automobiles, lithium ion battery, and nickel cadmium battery. Definitely you have to come across all these things. Each one will a individual cell, correct, which has 2 electrodes and electrolyte will produce a fixed amount of voltage, will produce a fixed amount of voltage or EMF, amount of EMF. Please note that it's called electromotive. Right word is the battery produces electromotive for EMF. Unit for that is volts. Because to honor the Italian scientists who coined the word volts, so many volts. If the EMF produced this much, the unit was defined by volta, correct? He is the one of the person who invented battery also. To honor him, we give unit for the EMF is volts. Nowadays, nobody is talking EMF. We say battery produces voltage. What is unit? 10 volts. It produces voltage, the unit is 10. That is wrong. Actually, produce a EM, correct technical word. This is what. Okay. So that means I have 2 electrodes. And it is and I am immerse this in electrolyte. This is my electrolyte. And one terminal, I call it as positive terminal. Other terminal, I call it as a negative terminal. Okay. So across this, if I put my voltmeter, it will show some amount of volts, EMF. It produces EMF because there's a chemical reaction happens at these 2 electrode surfaces. Chemical reaction happens at these both the electrodes. How? Due to the electrolyte. Please note that if let us start with talking about well-known the electrical storage device in automobiles. We call as lead acid battery. Lead acid battery. Generally, it contains lead and Pb and PbO as electrode. One is anode, other one is cathode. We'll see what it is. Correct? 2 electrodes and H2SO4. What is the sulfuric acid diluted with water? Diluted with water. Okay, this is called diluted. That is called as our electrolyte. This is called as electrolyte. So this electrolyte in lead acid battery is H2SO4 plus water. Correct? Generally diluted because this will be 10 to 15% of volume. Correct? If I have 1 liter of electrolyte in your lead acid battery, 100 to 150 ml will be your H2SO4, sulfuric acid pure, will be mixed with 85 to 90% or correct? Yeah. Say 90 to 85% of water. That is what we will be filled with this electrolyte. And there are 2 terminals I told you. One is called as PbO2, lead oxide. Dioxide is called lead dioxide. Okay. This is called as positive terminal. If you take your lead acid battery open, there will be 2 terminals. One will be made of PbO2, lead dioxide. O2, di means 2, we know that dioxide. That terminal is called a positive terminal. Other terminal is Pb, pure lead. That is called as negative terminal. And it is filled with the diluted H2SO4, which acts as a electrolyte. And the electrolyte reacts with PbO and Pb both, and it produces electrons and positive ion called hydrogen ions. We'll see what it is subsequently. So basically, if you see an electrical device, the basic unit is a cell. A cell consists of two electrodes and electrolyte in which it is immersed in a container which is non-conducting. So that means three important components. Okay. Now, before going further, the first cell, correct? The first cell made was by Volta and Galvani. There are two persons around 300 years before, around 250 years before, 1600s to 1650, 70s, around that, around beginning of that, they invented a working cell. Okay, they all electrical cells work on electrochemical cells because they are going to energy is produced. Electrical energy is in terms of electric flow or current flow. Current flow is due to flow of electrons produced by one electrode to other electrode through load. That's how it is. So this figure shows the first invented cell, which is called as voltaic cell or galvanic cell, because to honor these two people, they work to independently. Finally, the idea was met, and that is becoming a basic cell. It consists of two electrodes. One is made of copper, zinc, which was called as negative electrodes. These two electrodes are immersed in electrolyte. Again, it is a diluted H2SO4. Okay, so this is the first electrical cell, which is called a voltaic cell or galvanic cell. After that, many materials came and many different type of electrolytes were used, and we will see in subsequent slides. But basically, we understand how a basic electrical cell works. This galvanic cell consists two electrodes, copper and zinc, and it can produce 1.1 volt only. If I take diluted this one in a container, non-conducting container, correct, filled with diluted H2SO4, I take one copper rod, I take one zinc rod, I immerse inside this without touching. Then if I connect a voltmeter across this, it will show 1.1 volt. This voltage is fixed. It is a fixed voltage for given electrode material and electrolyte. Electrolyte H2SO4, electrodes are made of copper and zinc. Okay, so this is called as a unit cell. Okay, what is a battery? Battery consists of many cells connected in series or series parallel connection. We will see what it is. Series and parallel. Okay, so we know that basically how it works. I wanted to say that now that you took a container filled with diluted H2SO as an electrolyte, and you immerse a zinc electrode and copper electrode, then immediately chemical reaction happens between the electrolyte and the copper plate. You can see here. During the time, the H2SO4, correct? It consists of hydrogen atom and sulfur atom and oxygen atoms. Okay, that will be broken into H plus and electrons and SO4s separately. Okay, it disintegrates into electrons plus H positive. That means we call it, which is called as, I can say that, electrons, comma, H plus, which is called a positive ions. That means, you know that if I take an hydrogen atom, in periodicity, the first element, it has a nucleus in which there is a proton. Correct? I have a proton which is positively charged. Around the time, an electron is revolving. Correct? This is my electron, which is negatively charged. So this is what your hydrogen cell. And this H2SO4 has sulfuric acid, two hydrogen atoms, one sulfur atom, and 4 oxygen atoms. They are joined together chemically, bonding. Works as a single molecule. Correct? This one. All together, 2 plus 1 plus 4. 7 atoms are bonded together, which forms sulfuric acid molecule. Okay? So now, in which if I immerse with water diluted, if I immerse a copper rod in sulfur diluted summary acid, immediately this copper rod attracts, become positive cell because positive ions are there. Then the electrolyte is split into two parts. Correct? Electrolytes are split into two parts. Electrons and positive ions. Okay. Now, let me clear, then you will see what already written. The electrons are separated from the hydrogen atoms. Correct? They are free to move inside the electrolyte. Electrolyte liquid in which electrons can move. Okay. Similarly, hydrogen ions are produced. This is H plus ions. All these things came from by splitting this. That is what the chemical Rodux process, reduction and oxidation process. Okay. Now, you got here we shown that 4 H plus ions and 4 electrons are produced. Okay. Similarly, at the zinc plate, which is called a negative plate, again same H2O4 reacts with the zinc and it produces again H plus, correct? And which is called a positive zinc ions. These are positive zinc ions because pure zinc reacts with H2SO4, it releases positive zinc ion. That means these electrons are removed. So these are the electrons removed from the zinc material near the negative electrode. Okay. So then what happens? They start migrating. The positive ions will go to copper plate. The negative electrons will move to the zinc and they get deposited on the plate itself, on the surface of the plate. Okay. So that means copper electrode become positive of the battery. And since electrons are deposited zinc material, electrons have negative charge, they become a negative this one. This is how the basic electrochemical cell, which is also called voltaic cell, galvanic cell, first invented by around 200 years before. So now this is called one cell. Okay, this cell produces 1.1 volt only. For example, I want 2 volts, or I want to, for example, 2.2 volts for some reason, or I want 4.4 volts. An electrical circuit need. What I will do? Then I take one cell. This is 1.1 volt because this is symbol for cell plus minus, and to take another 1 voltaic cell, connect in series. This is called series connection. If I connect in series plus minus, you can see that minus of the one cell, this is I say C1, this I call C2 cell. C1 cell negative is connected to positive of the C2 cell, and C1 cell positive is connected to my load. For example, electric bulb. Correct? This is a bulb. It needs 2.2 volts. Correct? So then only it will glow. Then one cell is not sufficient. I connected 2 cells in series. They call series connection. So now the whole thing can be called as a battery. I told you battery is collection of cells, collection of soldiers. Correct? Collection of something is called battery. Group is called. So since here I put, what did you do? I put whole thing in one box. 2 cells. For example, I have one cell like this. I have another cell like this. And connect like this. This is the minus, this is the plus, and this is the plus. And connect my load, bulb, correct? Light is coming, and this is a cell 1, cell 2. Whole thing I pack inside one. Inside a bigger box. Please note the individual cell will be separated. You cannot have something like this. 2 electrodes, this is positive, this is negative, correct? This is negative. So in a single container, you cannot form 2 cells, not allowed. That means you need to have separate container in which there are 2 electrodes and the electrolyte. And again, one more. But whole thing can be packed in a single container, bigger container. So this is called as a battery. Correct? So we call this as a battery. If we talk about lead acid cell, which is used in automobile, we have 6 volt cell, 12 volt cell, 24, nowadays 48 volts. Lead acid battery, this is a battery, right? I'm going to talk later, we are going to see today itself. If I take a lead acid, this one, I'll have PB and PBO2, and filled with H2SO4 with water, plus water, right? So this is my lead acid cell, one cell. If I say battery, this cell will produce 2 volts. Basically, lead acid cell produces 2 volts. This voltaic or galvanic cell will produce 1.21 volt only. Okay. Again, we are going to see that if when we talk about battery, 2 things we need to. So that means in lead acid battery used for motorcycles, it is 6 volts. In cars, 12 volts, 24 volts, 48 volt truck and bus. Correct? So that means you have 6 cells connected in series, or 4 cells connected in series. 3 cells, sorry. 6 volts means total voltage is 6. That means there are C1, C2, C3, plus minus, plus minus, plus minus. So this is the whole thing is put in one container, which we see in for a 2-wheeler. More correct? You have the battery. That is 2 plus 2 plus 2. If I want voltage instead of 2 volts, I want 4, 6. I have to connect series connection. Correct? So if I connect cells 1 plus 2 plus, if I connect n number of cells, n into 2 will be the final output voltage of a battery. If n is 6, for example, 12 volt battery means it has 6 cells, where n is called number of cells. Correct? 6 cells are there in 12 volt lead acid battery, multiplied by 2, that's why 12 volts is output. If I talk about 24 volt battery, there are 12 cells, each cell produces 2 volts, 24 volts. 48 means 24 cells to 48 volts. This is how lead acid battery is working. Basic unit is, again, we talk about this one. Now, we talk about the electrode, what is the basic cell. I told you the chemical reaction happening at the anode and the cathode produces electrons and positive ions. Electrons and positive ions. The electrons will come to negative cell, correct? Negative electrode. The ions will go to positive cell. But because of that, this became a positive. We say that copper electrode in voltaic cell is a positive electrode, and this one. Now, if I want to connect a load, I can connect external load like this. It can be a bulb, correct? It can be a bulb. It can be a motor, right? It can be a, so there's a current flow happens. I is flowing. So this produces EMF. What is how much EMF is per electron? 1.1 volt, 1.1 volt. And if I connect a load as a resistance R, I say that this is 10 ohms. So the I will equal to, according to Ohm's law, EMF divided by R. EMF is 1.1 volt divided by 10. So we can say that 0.11 amps or 110 milliamps current will be flowing through this load. And if it is a bulb, it is going to give light. So many lumens of this one. This is a basic battery work. Whether it is a lead acid battery, lithium ion battery, nickel cadmium, or dry cell, or voltaic cell, this is the fundamental working principle. So first workable, usable electric cell or electrochemical, also called a galvanic cell or voltaic cell, develops a EMF across its electrodes and supplies electrical current. They supply I, correct? Electrical current, because EMF is produced. If EMF is according to the I equal to EMF divided by R. If EMF is not there, automatic current will become 0. Correct? Current is called as a dependent parameter. Correct? It is called dependent parameter. It depends upon the amount of EMF produced by battery for a given resistance value. Okay. So the flow of electrons from one electrode. Again, let me clear. If I connect my load for a generally we saw resistive load, I say RL. Actually electrons were generated where accumulated in the negative plate, zinc plate. From here, electrons are moving through the wire, through the load, positive, and already ions are there, correct? And ions are then become the neutral. the electric charge of the electron will be exactly equal to charge. I am talking about not mass. Electrical charge of what is the electrical charge of electron? Any idea? 1.6. Correct? Electron is 1.6 into 10 power minus 19 coulombs. Unit for electric charge is coulombs. Again, the person who invented, to honor him, coulomb is the unit. Individual electron, if you are able to capture and measure the charge using the appropriate, it will show 1.6 into 10 power minus 19 coulombs individual electrons. In your wire, trillions of electrons will go, correct? The flow of electron from the negative plate to the positive plate. Why it is flowing? In the positive plate, the positive charge is there. Oh, the ions. Hydrogen ions are there. They are attracting the electrons at the zinc plate. The electrons are produced by chemical reaction at both the plates. Electrons and ions are produced because of the voltage develops. We say potential, electric potential. Another name for the EMF is called electrical potential. Electrical potential produced in the battery due to the chemical reaction, which is called as a redox process. Reduction and oxidation of the losing electron and gaining electron is called as oxidation and reduction process. Reduction process means losing electron. Gaining the electron is called oxidation process. Correct? So this is the process which happens continuously. How long this will happen? The battery will produce the electrons, and if you connect, so suppose if you don't connect the external load, correct? If I don't produce external load, the electrons will be sitting here. The holes, the positive ions will be sitting on the copper plate, correct? You will measure voltage, it will be there, but the current flow is not there, available. That's why the battery is called an energy storing device. The energy is produced as long as the H2SO4 molecules are available. Correct? I told you. First thing what happened? This is broken into two parts. Hydrogen and SO4. There are set of process happens which will show in the next class or while we talking. Okay. So the H2 first the hydrogen molecules are separated. Two molecules are there. Atoms combined. They call individually called atom. If two hydrogen H plus H. Correct? They call a molecule. Correct? This is called as atom. Individual atom, when they join 2, 3, 4, and this hydrogen can mix with S plus O. Correct? Oxygen, again oxygen, again oxygen. There are 4 oxygen. Correct? O is there, connected, yes. All these things are connected. The whole thing is called as sulfuric acid molecule. This molecule will be broken into first H2 and SO4 separate. That happens because of the zinc material is touching the sulfuric acid. Normally, sulfuric acid will not automatically break into H2 and sulfuric from this H plus and minus electron. Final process. All this thing happen only when zinc electrode is immersed in the H2SO4. If I don't immerse copper into this electron, I keep only the H2SO4 diluted or this one, nothing happens for years together because they are chemical. H2SO4 chemical one, they remain as a sulfuric acid, diluted sulfuric acid only. But once I immerse zinc electrode, this happens. Once I immerse this one, this happens. That means already this one, the chemical reaction produces electrons, and they are stored in the zinc electrode. The ions produced during the process, which is called as electrochemical reaction, which is called a redox process, they reaches a copper, it becomes positive. They are waiting. Now, if I connect my load, that is, I say the circuit is closed. Connect my load, that means circuit is closed. Automatically, this fellow who was waiting, correct? Please note that the electrons here are wanted to go to the copper, but that doesn't happen. The electrolyte doesn't allow. Internal, the chemical mechanism doesn't allow. These electrodes stored in the zinc to reach the copper internally. You may ask why it's not allowed. Correct? There's a big problem. We are not going to discuss about it. One thing is this happens, and each electrode, the positive ions will come to the copper plate. Negative electrons will go, and that's it. They cannot go one way. This one, electrons will go like this, where and the positive ions will go in this direction and store, and they can wait there only. When they want, but they still get attracted. They wanted to join positive the sun. The fundamental nature are north and south polar magnet, and the positive charge and the electron negative charge. So that means they're waiting. If I connect load, immediately the electrons are start moving and they reach and they get neutralized. Okay, that's over. And for example, I have 100 H2SO4 molecules in my container total for understanding, correct? So each time one molecule becomes H plus and E minus. That means one positive, this one. So one electron is produced. Now, then what happens remaining? 90. Next second, next one. Please know that it happens continuously. For understanding purpose, it happens million, trillions. That depends upon surface area of the battery. Correct? Surface area of the battery electrodes. Larger the surface area, more sulfuric acid will get contact with zinc and copper plates. Bigger the area of the copper plates move inside this one, surface area of the copper plates and zinc plate touching the sulfuric acid, more the molecule will be broken into H plus and E electrons, and they come on this one. That means number of electrons decides what is the current flowing through the load, which called I. What is unit? Amps. Correct? We know that Q is the charge, individual charge, correct? D by dt of Q is called as I. Rate of flow of electrons, individual electrons, Q charge. How much? 1.6 to 10 power minus 19. So if 1 million electrons are flowing within 1 second, I'll say that 1 into 10 power 6 multiplied by 1.6 into 10 power minus 19, correct? So much charge is moving. So d by dt rate will go, I will flow. If I want more current, I should be more. That means more number of electrons should be produced at the zinc and copper plates. That means bigger the copper plate is larger area, surface area, more current. That means bigger the battery. Again, note down. Very important. Okay. So the size of the battery. Correct? Or cell. We are talking about individual cell. Correct? Size of the battery decides volume of the electrolyte. Correct? More electrolyte plus larger electrode surface area. That means more number of molecules will get in contact and more number of electrons are produced. More number of electrons are produced in your battery. So then more current will flow. I is proportional to surface area of electrodes which is in contact with electrolyte. Correct? So if I want more current and I need to make bigger cell. Correct? For example, I take a container which the volume is 10 ml. Correct? 10 ml is the sulfuric acid filled. I put electrodes. What is voltage produce? I am talking about copper and zinc electrode, this one. Correct? So positive and negative. It will produce 1.2. I take a big another container which is 1000 ml of H2SO4 diluted. I put again same Cu and zinc positive. Again, how much voltage will produce? Same 1.0 volt. No, I took much bigger this one. This is 1000 liters. I put 2 electrode, copper and zinc. How much voltage will produce if you measure? It will be 1.1 only. Correct? Whether the volume of the battery or amount of the battery holds the electrolyte, the size of the surface area, size of the electrodes will, even if you make bigger or smaller, even if you get 100 microliters, correct? A small container, you put 2 electrodes, micrometer diameter, still it will produce 1.1 volt only. Okay, that is the fundamental nature of the zinc or voltaic cell, correct? Copper zinc cell, which is called voltaic cell, correct? But the current depends upon number of electron created within 1 second. Bigger the volume of the cell, correct? 1 ml. So when I give the battery, what is the specification we are giving? To buy, you will see that voltage, correct? Voltage V equal to 1.1. What is the current? Correct? 10 milliamps, 100 milliamps, 1000 milliamps, 1000 amps, correct? All this depends upon the size of the battery. Depends on size of the battery. Bigger the battery, more current can it produce, because more volume of the electrolyte, bigger electrodes with larger surface area, more sulfuric acid molecule will get in contact with zinc and copper electrodes, split and produce electrons and charges. So more current can be produced. So we know that power equal to V into I. Energy produced by battery is integral of P. So if I want more power, more energy, I should have bigger battery, bigger battery, and so I have bigger electrodes. Bigger container, you put a small electrode, no use. The surface area matters. I have 10 liters container, but I put 2 electrode rod with the 1 mm diameter. The surface is cylindrical. We know the surface area very small. It will have a high current. If I want big, I need to put bigger electrodes also. So the surface volume increases apart from this one. Okay. This is applicable to any cell. If I talk about lead acid battery, 2 volts per cell. Correct? What is this one? Current can be 1 amps, 10 amps, 100 amps, or 1000 amps per cell. Correct? And this depends upon the size of the individual cell of lead acid battery. And this voltage remain constant. I have a lead acid battery, for mechanical size building, which volume may be 1 lakh liters, fill with electrolyte and put 2 this one electrodes. Okay, it will still produce 2 volts only. But if the electrode size are bigger, it can produce 1000 amps, 10,000 amps, because larger area. You got it? That's very important. Okay, fine. Next one is when we talk about electrical cell. When we talk about electric cell, as I told you, it has positive electrode called as anode, negative electrode called as cathode. Symbolically, this is represented by plus, and this is see in your battery also. Lead acid battery or automobile battery will be marked. That one is called anode and cathode. And the third one is, as I told, that electrolyte. Without electrolyte, there is no products process. So no electron production and no current flow. Up to no current flow through load. So this is very important. Okay. These parts are very important. Okay. Now, then we know that already the chemical reaction happens because of that EM is produced. Unit for that is volts. We already discussed. Now, next thing is, I told you the amount of voltage produced between the anode and cathode. Voltage produced between anode and cathode. This depends upon type of materials. Depends on type of anode and cathode material we are using. Right? I said copper and zinc in case of voltaic cell. In case of lead acid battery, Pb, pure lead, and PbO2, lead dioxide. They are used as cathode and anode material. So that combination, one is called anode material, other one is called cathode material. Okay. This combination decides the voltage. Okay. Okay. Now, if I take anode materials, we call this anode materials. Other one is called cathode materials. What are the anode material? Lithium, note down. In exam, you are expected. Okay. Then zinc, then lead, then copper, hydrogen. Even hydrogen gas can be used as a, they are called gas batteries or gas electrodes. There, and gold. Okay. Now, similarly, cathode material, ferrite materials. Okay. Iron oxide, ferrite materials and iron oxide, lead oxide, cupric oxide. Copper is oxidized form is called cupric. Correct? It is called cupric oxide. Copper oxide. It is basically CuO2. Correct? CuO2 is called cupric oxide. Then oxygen, similar to hydrogen, oxygen also can be used as a cathode material. Okay. So please, the one funny thing you should note, anode, we say anode material is called as negative electrodes. Anode material used to make the negative electrodes. Cathode materials are used to make the positive electrodes. I don't know why this is how the convention used, in which lithium is the most negative material. Most negative material, no doubt. And gold is the, there are many things. I am giving a few sets, correct? There are, in periodic table, you have many materials which can use the anode material and cathode. We are talking most widely used anode and cathode material, commercial use, which is useful, correct? And the gold is called as least negative material. Out of in periodic table, this is least negative. Most negative item is lithium. I will tell you when we talk about lithium battery. That's why lithium ion battery can produce 4 volts. The individual cell of a lithium ion will produce 4 volts. We know the lead acid will produce 2 volts. The copper and zinc combination produces 1.1 volt. Correct? So similarly, the nickel cadmium produces 1.4 volts or 1.3 volts, 1.2 or 1.3. I don't remember. I think it is 1.2 volts. Okay. So please note that in that lithium ion battery, lithium is used as a 1 electrode. Similarly, lead is used as a 1 electrode, Pb in lead acid battery. Copper is used as a electrode. Correct? In case of voltaic cell like this. So similarly, this in case of cathode material, which is we used to make positive electrodes of the battery, the ferrite material is the most positive. It is the most positive material, note down. Among this, what I listed, oxygen is the least positive material. Okay. Now, if I want to make a battery, I should take one anode material as an electrode. Then I should take another cathode material. As an electrode. Okay. Then I should use the appropriate, the electrolyte. There's a method how to select it because I'm not going to discuss, we don't have time. Okay. So now this combination decides what will be the voltage produced by this individual cell. Correct? In case of lithium, lead acid, lead is used as 1 electrode. Lead oxide is used as other electrode. If I use this combination, it will produce 2 volts only. irrespective of size of the battery. I make a battery earth size. Correct? I put two electrodes. One is lead, other one this one. Fill it with trillions of liters of sulfuric acid. Still it will produce 2 volts. But what is advantage? It can produce billions of amps of current because so much volume of the H2SO4 is there. And if I put a bigger electrode, more circuit, that means more reaction can happen on the surface. They produce billions or trillions or jillions of electrons. So then the current flow from anode to cathode can be connected load. It can produce. The size decides the current produced because the volume of the number of H2SO4 atoms touching the surface as zinc, Pb, lead, and lead oxide will be billions and trillions. So more number of electrons reduced, the current increases, but the voltage remain constant. This combination. So lithium ion combination, lithium uses both lithium material only, correct? And lithium has one electron, other one, and it can produce 4 volts. Lead acid 2 volts. And voltaic cell 1.0 volt. Dry cell, which uses zinc plus, it uses zinc plus zinc oxide. I think exact number you have to see. Correct? So it can produce 1.5, we call it dry cell. This combination. Another important thing, I will stop. I know that it is 7.5. I'll stop. You cannot use two anode as the same material. You cannot take anode material itself. For example, lithium plus zinc cannot be made as a battery, or zinc plus lead acid lead cannot be made as a. So left side anode material and it has to be used along with cathode. One will be positive electron, other will be negative. This combination cannot change. If you use same material, voltage will not be produced. With this, I stop here. Tomorrow we'll see how lead acid battery works. Then we'll see about lithium-ion battery working. Then we'll see about supercapacitors. Maybe within another 2, maximum 3 classes, I will complete energy story. Tomorrow, day after, and Thursday 2 hours. I wanted to complete the energy. Then we'll go to next chapter, which is talking about configuring, finding the calculation of the torque, power, or when we use hybrid vehicle, all those things we'll see. That may be another 4 to 5 classes. With that, we'll close it. Any doubt?
Sir, my request is, can you give the assignment sheet, sir?
Yes, I will send you. Maybe after this class, I will give the assignment sheet.
Yeah, because we will start writing on that.
Yes. I know that. I know. Last time I did the same thing. Definitely by this weekend, I will provide. Friday, I will send you assignment. You can start working. The questions will be from the first to last. What I am going to cover also. Correct?
Sir,
I'll give 10 questions. Correct? Maybe problems,
yes,
maybe write about batteries, all those things. They explain battery, how it works, equation, all those things. So, which will be useful for your exam. 10 questions, 10 marks. So, date of submission is on the day of exam, before the day of exam. Before the day of the exam, you have to submit. Correct? Scan and send it to me, and that will be typed for submission. The question will contain portion from what I'm going to teach, or don't worry. Ask you this one, you start working as a
syllabus for the instance.
yeah, the entire portion. Handsome always entire portion.
So that is what, sir. Just the weightage. Can you give more weightage for the post midsum syllabus, sir?
Yeah, see, because we are going to give 60 marks, correct? 30 marks midsum over, 10 marks for assignments. After 60 marks, approximately something around 40, that is 40 marks will be for after, 40 or the 35. And
That is what.
we will see how much portion we are covering.
Right, sir.
Correct. So if it comes from the previous portion, it is good for you, no? Already you have prepared.
Yeah,
More portion come from the previous, this will be better. So
Hmm.
generally, the after this one will be 40% or the 35%. After midsum, previous will be 20 to 25%. We'll see what it is. Don't worry. The assignment anyhow 10 marks will be there.
Yes, sir.
Okay. See you.
Thank you, sir.
Yeah.
Sir, and can you please also share the notes like means you said it earlier, right? So that would be useful, sir.
Yeah, we wanted to share because actually yesterday I was stunned to see in the internet. I was teaching something in the classroom about this one, basic electrical, many things. There is a website which uses my drawings, whatever I taught in the class, drawings, figures, all those things, put little bit text. And 2017 onward, he is running. Somebody, yesterday I was looking for something, I saw all the drawings, whatever it is, inductor, capacitor, working of this one, electrical transistor, all these things, the figures alone he has taken, because generally I make neat figures, you know that my PPT, he had taken these figures. I don't know how he got it. 2017-18, we are talking, and he is running a website using my this one. Only thing is, you'll put 1 or 2 words on the drawing, because copyright I should not ask, no. So I draw, for example, this figure is there. No, people are working there. I was surprised to see yesterday. For this figure I made, no. This figure is there. You will add 1 word in your, battery, something. Then he writes some text. And he is running a website. Somebody, I don't know who is doing. Really, I wanted to find out. And because I surprised to see that, but that's why sharing notes, I give it to students. Then students will start sharing in internet. I taught the class in Germany. They asked this same mechatronic course, correct? And I never give this one, all my slides. When I came back, I told in class, you should not share. I came to India. Within 1 week, the students, because in my class, there are some 5 to 6 Indian students, some 10 German students, 8 Chinese students. I don't know who did. And again, it is available on internet. If I share something, if I don't do, very next week, it is available. All my materials, what I teach, everything, they put and in the name and they start sharing. That is what I don't want to, because for this one, online courses, VMAT I am teaching for last 7 years, correct? At least 7 years, and 5 batches over. And never share material because this happens. People promise. I came from Germany, within 2 days that we entered. I was teaching control system mechatronics. All slides, they create their own web page and put the figures, and they start sharing. And people never listen. They never keep promise. That is another issue. Correct? One teacher, we say it is meant for you for your purpose, reading purpose. You say yes, and next day you share it to your friend in this one, and somebody start creating website. Literally
Sir,
Sunday,
Sir, we will not do like that. Whatever you can give some other issues, sir.
Yeah, we'll see. But please always take your notes. That is very important.
Yes. We are already noting out, sir.
Yeah, I know that. No. See, Arnasalam, before things happen, we don't know. But this is what every person is saying. Every class, IIT, BTech, German students, Indian students, Chinese students, everybody is saying who is doing, we don't know. We share the notes, all these things for the exam purpose. They cry, so without notes, we could not take all these things. They promise in the class. But within 1 week, I see on the internet. Without my permission. I sit and do preparation, all these things, 6 hours together. Okay, fine. We'll see what can be shared. We'll see. But please take the notes.
Notes, no problem.
Thank you.
Thank you, sir. Thank you.
Yeah.